In this question, we are given the earnings per shares and the dividend payout ratio and stuff, and we are asked to find the price. So there is no uncertainty here, so we will be using the discounted dividend model. So the first thing to do is to find out all the dividends. So I would recommend always drawing a timeline. So we start at time 0 and we are asked to find the price at time 0. And at time 1, 2, 3, 4, 5, we'll be calculating two things. The first thing is the actual earnings, and then we'll be finding out the dividends. And then the price is just the present value or the discounted value of the dividends. So to start with the earnings per share in the next period is $5. So here you need to read this carefully. It's the next period that the earning is $5. So the earning here is $5. And then we have the growth rate formula. The growth rate is the growth rate of the returns. So we use this formula. Growth rate is the retained earnings times the return on assets, or return on equity, sorry. So in the first 4 years, the growth rate can be calculated to be 0.05, and afterwards is 0.02. Therefore, it would grow at a rate of 5% in the first 4 years. 5 squared, 1.05 cubed, and starting from year 5, it would grow at a different rate. So this would be 3 times 0.12. So let me draw the year 6 as well. This is not a dot. 1.0. And so on. So now you know the earnings. Then calculate the dividends. It's just the earnings multiplied by the dividend payout ratio. The dividend payout is just 1 minus retained earnings. So at the beginning you retain 50%, so it means you pay out the other 50%. After 4 years you retain 20%, so it means you pay out the remaining 80%. So at the beginning it's just this 5 times 50%, and this is, sorry, 50%. And starting from year 5, you pay out 80%. So this is 1.02 times 80, and the same thing happens here. So the next thing is to add them up. So when adding them up, the very simple way is just to divide it by the discount rate, which you know the discount rate as, I think, 4%. 60, not 6%, 10%. Constant. Okay, the required rate of return, which is discount rate, is 6%. So the first one gets discounted by 6%. Second one squared. Third one cubed. And this one to the power 4th, and so on. And then you just do this thing plus the second part plus the third part plus the fourth part plus the thing afterwards is just a growing, infinitely growing perpetuity. So we cannot just add them up, we need a formula. So there is a formula for this kind of thing. You pay x times 1 plus g, and you pay x plus 1 plus g squared, dot dot dot. So the present value at this point will be x divided by r minus g. So note several things. So first is the X is the dividend in the next period. It's not in the current period. And the second thing is it's the R and G. Our R is the interest rate, which is 6% here, and G is 2%, which is the growth rate. And so we can use this formula for our question here, which X is just 5, this, and R minus G is 0.06. So remember, this formula gives you the present value of all these X's and the G's at time 1 period prior to the first X. So the first X here is 5. Sorry, I forgot the 0.8. So this is our X, this is our X1 plus G. So our value, the present value that we calculated by this formula here, which I have as PV, is at this point. So you need to discount this further by 4 periods. That's why we need the whole thing divided by 1.06 to the power 4. And you add all these 5 terms up, you'll get a value, and that value will be our price, which turns out to be 102.83.